All right, today we have an important objective. Find accumulated change over an integral using the fundamental theorem and an initial condition. So the fundamental theorem says that f of b minus f of a is equal to this integral. Therefore, if you add f of a to the other side, capital F of a, it would equal this. So what this says is if f of a is where you start, and then you add the integral from a to b, you would get f of b, which is where you end. And the integral from a to b can be thought of as what's called accumulated change. And basically, this is a really foundational idea, not just for this objective, but math in general. Where you start plus how far you go is equal to where you end. Where you start plus how far you go is equal to where you end. We've seen it before in a lot of different ways. This is just a very generalized way of saying it. And here's a problem where this comes into play. So the velocity of an object is given by this function, and its position at time equals 0 was 4. That means it starts at 4. This is an initial condition. Determine the position of the object at 1. Well, I want to know what x of 1 is. Well, x of 1 would be whatever x of 0 was, plus the integral from 0 to 1 of v of t, dt, because this is, of course, the derivative of position. I'm going to plug in numbers here, but what this says again is if you start at 0 and you accumulate this much change, you will end up at wherever x of 1 is. So let's plug in some numbers. X of 1 would then equal, well, x of 0 they said was 4, plus the integral from 0 to 1 of v of t, so that's 4t squared plus 2/3 dt. And now we can just evaluate this. And this time we're going to do it by hand, but this is something that a lot of times it's a calculator problem. This is going to be 4 plus our integral of this function is 4/3 t cubed plus 2/3 t. This is a definite integral, so we don't need a plus c. And we're evaluating this from 0 to 1. This is going to be a pretty straightforward one. 4 plus, I'll put brackets, when you plug in 1, this is just going to be 4/3 plus 2/3 minus, when you plug in 0, the whole thing comes out to 0. 4/3 plus 2/3 is 6/3, so this is all 2. So this whole thing just says 4 plus 2. So what that says is x of 1 equals 6. We started at 4. It turned out we accumulated a total of 2 units of change, and it came out to 6. Our next problem. This is super common on the AP test. The growth of a country can be modeled by this function. dp over dt is equal to 0.045 e to the 0.1 t. P is people measured in millions, t is time measured in years. Now they start to give us the initial condition. They said in 1990, the population of the country was 27.46. So I'm going to circle all this. The 1990 clearly is where it starts. So we've got an initial condition. Write an expression to find the amount of people in 2020 and then use a calculator to evaluate that expression. So I know that the population in 2020 is going to be equal to the population in 2019, or I'm sorry, 1990 it said, plus the accumulated change from 0 to 30, because that's 30 years, of that function dp dt. So 0.045 e to the 0.1 t dt. I'm going to make this a little bit better. I could rewrite it, and sorry if you already did this, but I'm going to write that actual number there. So the population in 1990 was 27.46 million. So this is the expression that it asks for. The population in 2020 is going to be 27.46 plus whatever is accumulated from 0 to 30 of this function. Now, this is just a calculator problem. It's expected to be, this is not something that you would be expected to do by hand. I know you can't see it, but I'm grabbing my calculator, and when I type all this in, it comes out to 36.048. You want to make sure this makes sense. So if the country's population was 27 million in 1990, does it make sense it would be about 36 million? Sure, those are both, kind of close to each other. So our population is 36.048 million people.